Okay students, today let us learn equations reducible to variable separable form. Clear? So for that let us consider one of the differential equation, that is dy by dx equal to f of ax plus by plus c. Clear? So now the differential equation is in the form of dy by dx equal to f of ax plus by plus c. Here what we have to do, we have to reduce this particular differential equation to variable separable form. So for that I will put ax plus by plus c equal to z. Ax plus by plus c equal to z, and let us simplify. If I substitute this, differentiation of this will be what? It will be a plus b into dy by dx. This is 0 equal to dz by dx. So this will be the form. Clear? So now if I take a on this side, it will be dz by dx minus a into 1 by b equal to dy by dx. Clear students? So for that what we have did, ax plus by plus c equal to z, we have substituted. So this equation will be what? That is dy by dx equal to f of z. So dy by dx equal to f of z. So therefore in this place I can write it as f of z. Clear students? So now this will be reduced to dz by dx equal to b into f of z plus a. Clear? So now it is in the variable separable form, so that we can integrate the term by variable separable form, so that we are going to reduce this particular function to variable separable form and we are going to solve. I think you understood how to reduce to the variable separable form. First you have to check the given differential equation is in the form of dy by dx equal to f of ax plus by plus c or not. If it is in this form, you have to put ax plus by plus c equal to z. Here in this place you have to put z. After substituting z, you simplify this by differentiating. You are going to have 1 by b dz by dx minus a equal to dy by dx equal to f of z. So in the place of f of z, see, you have 1 by b dz by dx minus a. If I simplify this, it will be in the form of dz by dx equal to df of z plus a. So now after this you have to integrate on both sides and you have to simplify. This is what your variable separable method, reducing to variable separable method. Now let us go on solving example on this. I will solve one example on this, so it will be very much clear. Okay students, so now let us solve one problem on the solution of differential equation dy by dx equal to 4x plus y plus 1 equal to 4x plus y plus 1 whole square. Clear? So dy by dx equal to 4x plus y plus 1 whole square. Let us reduce that differential equation to reducible for variable separable form. Then let us integrate. Clear? Already you know how to reduce the given differential equation to variable separable form. Clear? So for reducing variable separable form, first we have to check the given differential equation is in the form of dy by dx equal to f of ax plus by plus c is not. First we have to check this. Clear? So for particularly this reducible variable separable form, this is must and should. Clear? So I will check this given differential equation is in this form or not. So See this dy by dx, f of ax plus by plus c. Again it is 4x plus y plus 1 whole square. So it is in the form of dy by dx equal to f of ax plus by plus c. So for that what we have to do, replace this term as z. That means ax plus by plus c has to be replaced as z. So here replace 4x plus y plus 1 equal to z and simplify. Clear? So differentiate this. For differentiating this, what you are going to have? 4 plus dy by dx equal to dz by dx. This term you are going to get. Clear? Okay. So now you have replaced this term as z. Clear? Then you are going to have 4 plus dy by dx equal to dz by dx. Okay. Now this is equal to what? Dy by dx is equal to what? Dy by dx will be equal to z square. Dy by dx is going to be equal to z square. So in the place of dy by dx, what you are going to write? You are going to write z square, that is equal to dz by dx. Clear? So don't get confused. Again I will explain. This term is replaced as z. That means 4x plus y plus 1 equal to z. This term has to be differentiated. If this term is differentiated, what you are going to have? 4 plus dy by dx. Differentiation of 1 is 0. Now this is equal to dz by dx. Here this term is replaced as z, means dy by dx will be equal to what? This implies dy by dx will be equal to z square. So that I am going to replace in the place of dy by dx. In the place of dy by dx, I will replace it as z square. So it will be dx equal to dz by 4 plus z square. So now you have to integrate on both sides. If you integrate on both sides, integration of this term will be x equal to integration of this term will be 1 by 2 tan inverse of z by 2. Are you getting my point? Plus c. Clear? So see here, integration of this term will be 1 by 2 tan inverse of z by 2. You have to use the formula of integration of dz by a square plus x square formula. Here you have to use integration of dx divided by a square plus x square formula, that is equal to 1 by a tan inverse of x by a. This formula you have to use. So if you use this formula here, it will be 1 by 2 tan inverse of z by 2 plus c. Clear? Okay. So now I will multiply these two here. It will be 2x. You have c. In the place of c, you multiply it with 2. So let us write in the option it is k. If I multiply this 2 with c, it will be k. So that's why tan inverse of 2k. Tan inverse of 2k. Clear? Okay. So now tan inverse of z by 2 plus 2k. Clear? Okay. If I take tan inverse on this side, what it will be? Are you getting my point? If I take tan inverse on this side, what it will be? Let us see. Before that, you take 2k on this side. It is going to be, I will write this term as totally capital K. So 2x, this is capital K. 2k again a constant, so that's why I am writing it as capital K. This is equal to tan inverse of z by 2. If I take tan on this side, it will be tan of 2x plus k. 2 I will multiply here only, it will be equal to z. Z is what? Z is 4x plus y plus 1. So in the place of z, it will be 4x plus y plus 1. So therefore, what is your answer? Z is 4x plus y plus 1. 4x plus y plus 1. This side you have 2 times of 2x plus k. 2 times of 2x plus k. Okay. So now you have the term z. Z is 4x plus y plus 1. Okay. See the answer. You have 2 times of tan 2x plus k equal to z. Here z is what? Z is 4x plus y plus 1. 4x plus y plus 1. Therefore, 4x plus y plus 1 equal to 2 times of tan of 2x plus k. So that is 4x plus y plus 1 equal to 2 times of tan of 2x plus k is your answer. Clear, students? So see once again, this is the given differential equation. I will reduce it to variable separable form by substituting 4x plus y plus 1 as z. If I differentiate it, it is 4 plus dy by dx equal to dz by dx. Now what I will do, I will write dy by dx, because here you have dy by dx equal to what? You have replaced this as z. So dy by dx equal to z square. So that is 4 plus z square equal to dz by dx. This term will become z square. Okay. So 4 plus z square equal to dz by dx. Dx equal to dz by 4 plus z square. If I take 4 plus z square and if I simplify, it will be dx equal to dz by 4 plus z square. Very easy simplification, no problem. If I integrate on both sides, it will be x equal to 1 by 2 tan inverse of z by 2 plus c. Okay. Then take the LCM. I will write c as 2k, because c is multiplied with 2. That's why I will write it as 2k, no problem, constant term. So 2k again I will take it as capital K, because it's a constant term. If I multiply two constant terms, again it will be a constant term. I will write it as capital K, no problem for that. Then take tan inverse on this side. It will be tan of 2x plus k. You have divided by 2. If I take divided by 2 on this side, it will be 2 times of tan 2x plus k equal to 4x plus y plus 1. So this is your answer, that is your option D. Okay. Okay, students. So now I will go for the second type of reducible to variable separable form. Clear? So now we are studying the differential equations to reducible for variable separable form. Clear? That means they will give you one differential equation. In that differential equation, you have to check, is it reducible for variable separable or not, and then you have to solve that. Clear? Already we have seen one of the reducible, one of the differential equation which is reducible for variable separable form, and we have solved one question also on that. Now let us go for the second type, where the given differential equation is reduced to variable separable form. Clear? Okay. So here what they will do, the differential equation will be in the form of dy by dx equal to ax plus by plus c divided by capital AX plus capital BY plus capital C. Clear? This will be the form of given differential equation. To reduce it to variable separable form, first you have to check the ratio A by A is equal to ratio B by B for the same constant. Clear? Small a divided by capital A must be equal to small b divided by capital B. That must be equal to the same constant, that is k. Are you getting my point? If they are equal to k, then a will be equal to capital A into k, small b will be equal to capital B into k. Are you getting my point? That means in the given differential equation, if it is in the form of ax plus by plus c divided by capital AX plus capital BY plus C, there you have to check small a divided by capital A is equal to small b divided by capital B, and both the term must be equal to the same term. Clear? So that is a by capital A is equal to b by capital B, that must be equal to k. Are you getting my point? So small a is equal to capital A into k, small b is equal to capital B into k. Are you getting my point? So for that reason, see here, small a can be written as capital AK, small b can be written as capital BK. Clear? So that is dy by dx is going to be equal to k times of capital AX plus capital BY plus C divided by, you are going to have capital AX plus capital BY plus C. Now you are going to have this form of differential equation. So in this differential equation you have to put ax plus by equal to z. Ax plus by equal to z, and you have to differentiate. Clear? If I differentiate this, you are going to have a plus b dy by dx equal to dz by dx. This term you are going to get. Clear? So if you get this term, then what you can write dy by dx here? See, dy by dx can be written as dy by dx is equal to dz by dx minus a multiplied with 1 by capital B. 1 by capital B. Are you clear? So now your dy by dx can be replaced as this term is z, this term is z. So dy by dx can be replaced as k into z plus c divided by z plus c is equal to dz by dx minus a multiplied with 1 by b. So now dz by dx can be written as see here, dz by dx is equal to b times of kz plus c divided by z plus c. B times of kz plus c divided by z plus c plus a. Clear? So now it is in the form of variable separable form, so that you can integrate on both sides and you have to simplify the given particular problem. So please remember, in the given differential equation, is it in the form of dy by dx equal to ax plus by plus c divided by capital AX plus capital by plus c is or not? After that, you have to check the ratio a by a and b by b. They must be equal to the same constant. Clear? After that, here you can write k times of capital AX plus by plus c, ax plus by plus c. So further, you know what you have to replace the terms, and you are going to replace the z. So that is ax plus by plus equal to z. You have to differentiate this because you are putting ax plus by plus equal to z. This term is z. So that you have to differentiate. If I differentiate that, you are going to have a plus b into dy by dx equal to dz by dx. Further, you can simplify. You are going to have this. So you are going to have this. In the place of dy by dx, you can replace kz plus c divided by z plus c, because see here, this term is z, this term is z. Clear? So k into z plus c equal to dy by dx. I am going to write that term here. Further, if you simplify, you will have this, which is clearly in the form of variable separable. Now you can integrate on both sides. Clear? Now let us solve one of the problem on that and let us see. Okay students, now let us solve one problem on the reducing of given differential equation to variable separable form. First method is already over. On second method we have discussed the theory. Now I am solving one problem on that. Clear? Okay. So in the second method, what we have to do, the given differential equation is in the form of ax plus by plus c divided by ax plus by plus c or not. You have to check. Clear? So given differential equation is in the form of this or not, that you have to check. And with this, the ratio of a by a must be equal to b by b. Then let us solve with that method. If it is not in that form, it is not going to be in the form of variable separable. Clear? For that there is another method, you have to follow that. Okay, first let us check this ratio. Small a is 1, capital A is 2, here small b is minus 2, capital B is minus 4. So no problem. Again this will be equal to what? 1 by 2. Clear? So small a by capital A is equal to small b by capital B. Now we can apply our second method of reducing the given differential equation to variable separable form. So for that, what we have to do? We have to put ax plus by equal to z. So ax plus by means what? X minus 2y is equal to z. X minus 2y is equal to z. If I differentiate this, 1 minus 2 dy by dx equal to dz by dx. Clear? So this equation you are going to have. Now let us replace dy by dx. Let us replace dy by dx. See, dy by dx. In dy by dx, what you are doing? You are substituting x minus 2y is equal to z. So it will be implying what? Dy by dx is equal to z plus 1 divided by 2 times of z divided by 2 times of z you are going to have. So in the place of dy by dx, I will write that. So that is 1 minus 2 times of z plus 1 divided by 2z divided by 2z equal to dz by dx. So now we can cancel 2 and 2. So z will get cancelled. It will be minus 1 by z equal to dz by dx. This you are going to have. Now clearly it is in the form of variable separable. You separate the variables, it will be minus dx equal to dz. Minus dx equal to z into dz. Minus dx equal to z into dz. So if I integrate on both sides, you are going to have minus x equal to z square by 2 plus c. Z square by 2 plus c you are going to have. So now if I multiply this 2 for this, you are going to have z is what? Z is x minus 2y. So you are going to have x minus 2y whole square. I will multiply 2 for this, it will be minus 2x. So if I take on that side, it will be plus 2x equal to c. LCM is 2. 2 multiplied with the constant term again is a constant term. So I will write it as again c. No problem for that. Z is x minus 2y whole square. So x minus 2y whole square divided by 2. 2 can be multiplied with this minus 2x. Take on that side, it will be plus 2x. So x minus 2y whole square plus 2x equal to c will be your answer. So let us see which option. See D, x minus, sorry, not D, x minus 2y whole square. Okay, x minus 2y whole square plus 2x equal to c. Option A is correct answer. Clear, students? So this is how you have to reduce the given differential equation to variable separable form, and you have to simplify. Okay students, now we have studied variable separable form. Now let us go for homogeneous differential equations. Clear? Homogeneous differential equation. Clear? So before going to homogeneous differential equation, you must know what is homogeneous function. Clear? So for that, let us see what is the definition of homogeneous function. Clear? The function in the form of f of x comma y, the function in the form of f of x comma y is called homogeneous, is called homogeneous. Clear? That means your function must have two variables. The function must be in two variables. That particular function is called homogeneous function. Clear? In other words, if you want to say, if I take anything as a common, either x or y, you can take either x or y, inside the function, the variables must not get separated. They should be in the homogeneous form. So for that, we call it as homogeneous function. Okay, if the function is in the form of f of x comma y, we call it as homogeneous function. Clear? That means the function must contain two variables. If I take any term as a common, the variables must not be separated. Clear? So if in that situation you have any problem or any function, that is called as homogeneous. In words, you can write it as the function in the form of f of x comma y is called homogeneous function. Clear? Okay. On the same way, nth order of function also let us see. Nth order of homogeneous function. That means if f of lambda x comma lambda y is a homogeneous function, it must imply lambda n is equal to f of x comma y. That means you can take a lambda as a common term with the power of n. In this situation, we call the homogeneous function with nth order. For this, we call it as the homogeneous function with nth order, so that where you are taking lambda to the power of n as common from f of lambda x comma lambda y. Clear? So this is what homogeneous function and the nth order of the homogeneous function. Now let us go for the differential equation which is in homogeneous form. Clear, students? For that, you see here the differential equation in the form of dy by dx equal to f of x comma y divided by g of x comma y will be the form of homogeneous differential equation. Clear? So here from this, if I take x common, it will be equal to f of y by x divided by, here if I take common x, it will be g of y by x. So this is what your homogeneous differential equation going to have. dy by dx will be in the form of f of x comma y divided by g of x comma y. From this, if I take x term as a common, it will be x into f of y by x, x into g of y by x. Now, further you have to solve the homogeneous differential equation. Here what you have to do to simplify this homogeneous differential equation, you have to put y by x as v. You have to put y by x as v. Clear? So put y by x as equal to v. So now y is going to be equal to what? Vx. Clear? So if you differentiate it, it will be dy by dx equal to v plus x into dv by dx. Clear? So in the place of dy by dx, you write this v plus x into dv by dx, that is equal to, here x and x will get cancelled, that will be capital F of v. That will be equal to, this term I will write it as capital F of v, so that it will be in the form of dv divided by f of v minus v equal to dx divided by x. So further you can integrate on both sides and you can simplify so that you will get the required solution. Clear, students? So first you must know the given differential equation is in the form of homogeneous or not. So for that, you see, if I take x as a common from the differential equation, it will be reducing for y by x or not. If it reduces for y by x, then you have to solve it by homogeneous differential equation method. Clear? So while solving homogeneous differential equation method, you have to put y by x as v. So y by x as v means if I differentiate, you are going to have v plus x into dv by dx. In the place of dy by dx, you write this term, this complete term, I will write it as capital F of v. Clear? So if you simplify this, it will be in the form of dv divided by f of v minus v equal to dx by x. Now integrate on both sides. So you are going to have your required solution. Clear? Now let us go for problems on this. Okay students, now let us solve one of the problem of homogeneous differential equation. Clear? So the given differential equation is in the form of x square dy by dx equal to x square plus xy plus y square. I can write it as dy by dx is equal to, I will write it as x square plus xy plus y square divided by x square. I will write like this. Clear? So now in small quick time you have to check what is the highest power 2. You take any term common, either you can take x square or you can take y square. If you take x square, it will be in the form of y by x. If you take y square, it will be in the form of x by y. You take x square outside, see here, it will be y by x, it will be y square by x square. Are you getting my point? If I take x square from the denominator, x square from the numerator, it will be 1 plus y by x plus y square by x square. That means it will be in the form of homogeneous, because the given function will convert to y by x. So it will be in the form of homogeneous, that is dy by dx equal to 1 plus y by x plus y square by x square. By taking the terms common, and if I eliminate x square, you will get y by x plus y square by x square. Take the x square term common and you cancel those. So you are going to have 1 plus y by x plus y square by x square you are going to have. Clear? So clearly it is in the homogeneous form. For that, put y by x equal to v. Put y by x equal to v. So that is dy by dx will be equal to v plus x into dv by dx. So it will be dy by dx equal to v plus x into dv by dx. Okay. So now what we have to do? In the place of dy by dx, you have to write v plus x into dv by dx. In the place of dy by dx, you write v plus x into dv by dx, that will be equal to 1 plus v plus v square, because y by x is v. So now you can eliminate v and v. So it will be dv divided by 1 plus v square, and that is equal to dx divided by x. Clear? So dv divided by 1 plus v square equal to dx divided by x. So now you can integrate on the both side. So if you integrate on the both side, you are going to have tan inverse v equal to log x plus c. Tan inverse v equal to log x plus c. So that is v can be written as tan inverse of y by x equal to log x plus c. Now you can check your answers. Clear? So that is tan inverse of y by x equal to log x plus c. Tan inverse of y by x equal to log x plus c will be the correct answer. Therefore, option A is the solution for this given homogeneous differential equation. Clear, students? Now let us go for the second problem. Okay students, now let us move for the second problem. Clear? So the given differential equation is 2xy dy by dx equal to x square plus 3y square. So this can be written as dy by dx equal to x square plus 3y square divided by 2xy. Clear? So further, if I simplify that, it will be dy by dx equal to, cancel x and x, it will be x by 2y, cancel y and y, it will be 3y by 2, it will be 3y by x. That means dy by dx equal to x divided by 2y plus 3 by 2 y by x. Okay. So now again this is in the homogeneous form. So for that you have to put y by x as v. So y by x as v, put y by x as v. This implies dy by dx equal to v plus x into dv by dx. Clear? So again in the place of dy by dx, what you can write? See here, in the place of dy by dx, what you can write? This implies dy by dx equal to, this is x by v, that means 1 by 2v plus 3 by 2v. Clear? Because y by x is v. If y by x is v, x by y will be what? 1 by v. No problem with that. But in the place of dy by dx, what you can write now? 1 by 2v plus 3 by 2v. Clear? So I will write here, that is 1 by 2v plus 3 by 2v equal to v plus x into dv by dx. Clear? Okay. Further you can simplify the terms, so that I will take v on this side. It will be 1 by 2v minus v. So that is 1 by 2v minus v plus 3 by 2v equal to x into dv by dx. Clear? So here you can simplify 1 by 2v, v minus v, 3 by 2v. So LCM will be what? 2. LCM will be 2. So therefore 1 minus 2 minus 1 minus 1 plus 3 plus 2. So it will be 2v divided by 2 equal to x into dv by dx. Clear? Because LCM is 2. Sorry, LCM is 1 by 2v. You can't write like this, because this term is 1 by 2v. Clear? So you can't take LCM and you can't simplify. So for that, minus v plus 3 by 2v you have to simplify. If you simplify that, here again LCM is 2, minus 2v plus 3v will be v. So that is 1 by 2v plus v by 2 will be equal to x plus dv by dx. Clear? So 1 by 2v plus v by 2 will be equal to x into dv by dx. Okay. So now if you want to simplify, see here, the LCM will be 2v. The LCM will be 2v. For that, here you have to multiply with v, so that 1 plus v square divided by 2v will be equal to x into dv by dx. Clear, students? So if you take the terms and if you integrate, it will be dx by x equal to 2v divided by 1 plus v square into dv. Clear? So now you can make integration on both sides, so that it will be log x equal to log of 1 plus v square plus log c. It will be in the form of log x plus log of 1 plus x square plus log c. See here, plus log c can be multiplied here or on this side, no problem. Clear? So for that reason, I will take plus log x on another side, because according to our problem, let us see, if I take plus log x on this side, there is no problem. Clear? Because c is integral constant, so that's why I can write it on anywhere of the both sides. Clear? So log c plus log x equal to log of 1 plus v square. So it will be cx equal to v is y by x, x square plus y square divided by x square. If I multiply it to this x, it will be x cube. C into x cube equal to x square plus y square will be your answer. So no problem. In the place of C, they have written P. Clear? So x square plus y square equal to px cube is your answer. So no problem. They have written the constant as P. I have written as C. Just notation is changed. But solution of the problem is correct. For that, no problem with any doubts. Clear? So please make sure that if here your calculation is fast, you can solve very quickly. If I solve very quickly, I can jump. See here, I can jump all these steps. This step and this step you can jump, and directly you can go for dx by x equal to 2v divided by 1 plus v square into dv, and you have to simplify. That is also possible, but in detail to know the answer how to simplify, I have solved step by step. No ways. If you want to skip the steps, you must have a practice. But first you understand one by one the problems. If you solve this type of 10 or 15 problems, then you can skip the steps because you will be more perfect. Clear? We are just solving the second problem, so that's why I am solving each and every step. As we go on, I will skip one by one steps. You have to understand. Clear? So now I think you got my answer, that is x square plus y square equal to px cube. Okay students, so now let us go for linear differential equation. Clear? We have solved variable separable method, homogeneous method, and now let us go for linear differential equation. So linear differential equation means the differential equation in the form of p naught dn y divided by dx to the power of n plus p1 d to the power of n minus 1 y divided by dx to the power of n minus 1 plus p2 into d n minus 2 y divided by dx to the power of n minus 2, so on. It will be pn dy divided by dx plus pn minus 1. This is pn minus 1 will be dy, pn minus 1 into dy by dx. Pn will be multiplied with y, that is equal to q. Clear? So if the differential equation is in the form of like this, we call it as linear differential equation. Clear? So that means first point for the linear differential equation, order and degree must be 1. That means we are going to solve only this type of linear differential equations in our syllabus. That is, order and degree is 1 of the given linear differential equation, and if the differential equation is having order and degree as a 1, we call it as linear differential equation. Second point, product of independent variable. Product of independent variable and differential coefficients. Differential coefficients must not be present. For the linear differential equation, this is the second point, that is product of product of, sorry, not independent, dependent, not independent, dependent, product of dependent variable and differential coefficients of that dependent variable must not be present. That means y into dy by dx cannot be present. Y into dy by dx cannot be present in the given differential equation. If this is present, then that is not called linear differential equation. It is called as non-linear differential equation. First thing, order and degree must be 1 for the linear differential equation. If order and degree is not 1, it is called non-linear differential equation. Second thing, dependent variable and differential coefficient of dependent variable must not be in the form of product in the given differential equation. See this is not linear differential equation. Clear? Next, third one, exponent of dependent variable. Exponent of dependent variable must not be more than 1. Must not be more than 1. Clear? If, see here, dy by dx plus y square into x equal to q, like this, if it is present, that means exponent of dependent variable is more than 1, then that is not going to be linear differential equation. I am giving just this as an example so that you must not have any confusions. Clear? So the power of dependent variable cannot be more than 1. Clear? So if these three conditions are true, then we called that is linear differential equation. Clear? In linear differential equation, again there are two types. Clear? One is dy by dx plus ry equal to q. Second one is dx by dy plus rx equal to q. So we shall see one by one the problems on that and the method of solving those two things. Clear? First, be perfect to identify linear differential equation or not. If that is correct, then you can apply the method of linear differential equation, any one of these, and you can simplify. Clear, students? Okay, now let us see some of the problems. Okay, students, now let us solve one of the problem on finding linear and non-linear differential equations. Okay, see here, which of the following is non-linear, they are asking. Which of the following is non-linear, they are asking. Okay, so for non-linear, what you must have, you must know what is linear. Clear? If you know what is linear, then the remaining thing will be the non-linear. Clear? Okay, for that, first one, order and degree. Order and degree must be 1. Order and degree must be 1. So see, all the options are having order and degree as 1. Clear? And the second one, product of dependent variable and its differential coefficient. Its differential coefficient must not present for linear. Clear? So see here, order and degree must be 1. So all the 4 options are having order and degree, no problem. Second one is product of dependent variable and its differential coefficient must not present for linear. That means y into dy by dx must not present for becoming linear. That means what? If this is present, then it is called non-linear. Are you getting my point? See here, if this is not present, it is called linear. If it is present, it is called non-linear. Let us check that type of thing. See, dy by dx, no coefficient, no problem. So it is linear. Okay, see here, dy by dx into y. Here product of dependent variable and its differential coefficient is present. Therefore, it is non-linear. Clear? Come to the third one. Dx, no coefficient. Dy, no coefficient, no problem. Dy by dx, here no coefficient, no problem. So option B will be the correct answer for which of the following is non-linear. This is non-linear, but this is not linear. Are you getting my point? This is not linear, so it is non-linear. Clear? So option B is correct because product of dependent variable and its differential coefficient both are present in the product form. Okay. Now let us go for the next problem. Okay. Okay students, now let us go for the second problem on finding linear and non-linear. See here, which of the following is linear? Now they are asking which of the following is linear. Previous was which of the following is non-linear. Clear? Okay, to be a linear, it must have order and degree must be 1. Okay, in the first thing, order is 2, degree is 2. So this is non-linear. Clear? Okay, come to the second one. See here, order is 1, degree is 2. If you remove from the radicals, are you getting my point? If you simplify the radicals, then order and degree will be not the same. So it is also non-linear. Next, come to this dy by dx. This is not equal to, this is plus dy by dx plus y by x equal to log x. So here with this there is no dependent variable function. So there is no product of dependent variable and differential coefficient. Order and degree is also 1. Therefore it is linear differential equation. Now come for the fourth one. See here, product of dependent variable and its differential coefficient is present. So this is non-linear. So option C is correct for you for the particular question. Now I think you are clear about linear and non-linear. So if you are perfect in finding linear and non-linear, then the further things will be very easy for solving you the differential equations. Clear? If you find it is linear or not, then you can apply any method of the two which I have already explained. From that we can solve the differential equation. Before that you be perfect for finding linear and non-linear differential equation. Clear? So in this particular, this is non-linear, option C is linear, option D is non-linear differential equation. Clear students? Okay students, now let us see how to solve the linear differential equation. Clear? Okay. First thing, you have to check it is linear differential equation or not. For that, dy by dx plus py equal to q. This is one. And the second one is dx by dy plus px equal to q. Clear? So if the equations are in this form, then they are linear differential equation. Clear? So see here, order is 1, degree is 1, independent variable multiplied with the constant p, sorry, dependent variable multiplied with the constant p. Here p can be in the function x or it can be constant. P can be function in x or constant. Are you clear? Next q, also same. P and q can be function in x or constant. Clear? So p and q, they can be constant or they can be in the function of variable x, not in the variable of y. Are you clear? So if this is present, first thing you have to find integrating factor, that is if. You have to find integrating factor, that is if, that will be equal to e to the power of integration of p with respect to dx for this. Clear? By calculating if, you have to solve y into if equal to integration of q into if with respect to dx plus c. Clear? So first you check it is linear differential equation or not. If this is present, then it is linear differential equation. In this you have to check p and q are the function in x or not, or they are constant, no problem. If they are constant, no problem. If they are function in the variable x, that is also no problem. Clear? So after finding that, you take if, that means integrating factor is equal to exponential of e, that means e to the power of integration of p with respect to dx. After calculating if, you have to simplify this equation, that is y into if equal to integration of q into if dx plus c. Clear? Next, coming to this, here p and q, must be variable function in variable y, function in variable y. Here function in variable y or constant. It can be function in variable y or it can be constant. Clear? Next, after finding this, you have to calculate integrating factor, that is e to the power of p with respect to dy. Next, after calculating integrating factor, you have to simplify y into if equal to integration of q into if with respect to dy plus c. You have to simplify this, then you will get the solution of that linear differential equation. Clear, students? So please remember one point. In the linear differential equation, if it is with respect to x, in linear differential equation it is with respect to x, then p and q must be the functions in the x or constant. Must be functions in the x or constant. Clear? See here, if it is respect to y, that means differential equation is with respect to y, p and q must be constant or functions in y. Must be constant or functions in y. Using this p, you have to calculate if. Here also you have to integrate with respect to y. Using that, again you have to simplify. Here also integrate with respect to y. But in this case, it is with respect to x. While finding if, it has to be integrated with respect to x. While solving, it has to be solved with respect to x. Are you clear? So you keep this in mind while solving the linear differential equations. Clear, students? So from the next time, let us try to solve
the problems on linear differential equation. Clear, students? So in the next session I will start problems on linear differential equation. So keep in mind, while solving linear differential equation, you have two types. Either it may be dy by dx or it may be dx by dy. P and Q, you must know the conditions for P and Q, and you must know the formula of integrating factor. Here also you must know the formula of integrating factor. After calculating integrating factor, you have to simplify this equation. If it is dy by dx, here also same. You have to simplify this equation with respect to y. Here you have to simplify this equation with respect to x. Clear, students? Okay, let us continue in next session.